Will it burn with Miss B? Okay, we're going to talk about where the light comes from, how we get the different colors when I burn things. I'm going to start with the atom. The atom has protons and neutrons in the nucleus. That is not what we generally deal with when we deal with an atom. What we're doing when things combine, we make compounds, we produce light, we're playing with the electrons. So what happens is you give energy to an electron. It has a certain amount of energy inherent. We call that the ground state. But then we can give it energy from another source of light, from electricity, from a chemical. We can do energy into the electron. When we do that, it causes this electron to jump to a higher energy level. Or maybe it jumps 2 energy levels, depending on what we give it. When it jumps, it can't stay there. If I were to tell you to jump up in the air, you're going to fall back down because gravity is going to pull you. Well, the proton is going to pull the electron back to its ground state. So when it gets pulled back to its ground state, it's going to release a certain amount or quanta of energy, and that energy is going to travel in the shape of a wave, and that is light. That's how light is produced. So depending on how far we cause it to jump will determine when it falls back down, we're going to get different spectral lines. So even though this is not the normal actual shape of an atom, this is what we use to teach it. This was done by Bohr, Niels Bohr. And he then took the hydrogen atom and he looked at what spectral lines we're going to achieve based on where the electron fell to. Did it fall back to these different energy levels? So the first level closest to the nucleus is N1, and then it goes forward N2, N3, up to N7. So when he was doing this, he tested and he found that if it fell back to N1, from any of these, if it fell back to level N1, you got these 6 spectral lines, depending on. But these are so high in energy that they are in the ultraviolet range. So we don't actually visually see them. So if you had a spectroscope, you're not going to see these because they're not visible to us. He also did where they're going to fall back to N2. And he found these spectral lines. They're green, but this is just representing what they do. And it's because of where they fell to. And this is in the visible spectrum. So we'd get a visible spectrum within falling down to N2. These last 2 groupings are such low energy that they actually are in the infrared range. So we wouldn't visibly see these, but you can record them with detectors, so he knows they were there. So he developed this model of the atom and then further tested it with the hydrogen atom to determine what we're going to see from it. So the colors depend on where it was sent, but then where it fell back to, and we'll get other lines. So I'll go through some other elements in future videos and tell you what energies were there and what spectral lines we're going to get depending on what we're exciting. But this just gives you a general overview. Hope you enjoyed it.